Ever wondered how to handle massive datasets with lightning speed? In the next 30 seconds, I will show you what's coming up in today's video, where we master PySpark DataFrames. We will cover everything from creating and loading data to perform powerful analytics using functions like groupBy, filter, and aggregate. And stick around until the end because I just got back from the Big Data in Healthcare conference right here in London, and I will be sharing my key takeaways as a special bonus tip. You don't want to miss this, so let's dive in. Welcome back to Irish Cakes. This is Sayed here. In the last video, we introduced PySpark DataFrames. Now let's explore them in more details. Understanding distributed data frames. While the concept of data frame is familiar to Pandas users, PySpark's implementation is fundamentally different due to its distributed nature. A Pandas data frame exists on a single machine, but a PySpark data frame distributes data across a cluster. This architecture is crucial for the speed and scalability needed to process big data efficiently. Data frames are central to PySpark, supporting essential tasks like filtering, grouping, and aggregating on these large distributed datasets. They also offer a powerful SQL-like interface for data manipulation. Although the syntax might look familiar to Pandas, remember that PySpark's execution on a cluster make its behavior distinct. Creating data frames from files. Let's create a data frame. A common way to load data is from a file using spark.read.csv. This function can read a CSV file directly into a data frame. We can use arguments like header is equal to true to specify that the first row contains column names and inferred schema is equal to true, to have Spark automatically detect the data type of each column. Displaying data frame contents. To preview the data, you can use the .show method, which displays the top rows of the data frame. While it's possible to create a data frame manually with the create data frame function, reading from a source like CSV is typically faster and more practical for real-world large-scale data. Inspecting the data frame schema. To see the structure of your data frame, including column names and their data types, use the .printSchema method. You can see on the screen what is the output of .printSchema for the sensitive data frame. Performing basic analytics on PySpark DataFrames. Once data is loaded, you can perform analytics, simple aggregations such as using the .count method to get the total number of rows will return a single integer. For more complex summaries, you can change the groupBy and aggregate methods. For example, you can group the data by a gender column and then calculate the average salary_USD column for each group. This combination is powerful for quickly summarizing data and driving insights. Core data frame functions. 4 essential methods for data manipulation are select, filter, groupBy, and aggregate. Their functions are analogous to SQL commands. Select chooses specific column, filter works like the where clause to select rows based on condition, and groupBy categorizes data. Aggregate is then used to apply aggregate functions like sum to these groups. Example of key functions. As an example, you can see on the screen, you could filter the data frame to find all the rows where the age column is greater than 50 and then select just the columns you need from that result. You can see the output on the screen where the age and occupation is mentioned in the table. So, it's time to practice. Now let's put these PySpark data frame concepts into practice. Okay, so now let's practice PySpark in Databricks. So as usually, let's log into your Databricks account and go back to the notebook that we were working previously. This notebook is named Census Data Analysis. Open the same notebook And in the last tutorial where we have practiced, PySpark, how to read a data frame, how to upload a data set into the volume, and from the workspace, how to, get the URL and, paste it in this cell and then run the cell and should get the output and display the output, right? And how we have also learned how to print the schema, you can see over here, and we have learned how to display it in a nice tabular format in Databricks, right? So now in this today video, what we will going to do, we are going to learn how we can actually start some analysis, some basic analytics on PySpark DataFrames. So let's get started over here. So we can add like a new code cell here. Let's click on this, and over here we will just do, let's suppose we have learned how to count number of rows in data frame, right? So what we can do, we can over here we can do row count is equal to census underscore df dot dot count. Okay, and then over here we can, what we can do is print this number of rows. So you can do print statement over here, and then we can do the number of rows, and then you can just simply type the rows itself, the variable that we have declared earlier, which is row underscore count, right? Now this is like this will count the entire number of rows in the census data frame that we have, and it will display it on the in the cell as an output. Let's see what the output is. See, the number of rows is 4,000, sorry, it's 48,842 records in the dataset, right? That's nice. Let's move on to the other step that we have also learned for the analytics purposes on the data frame. Like we can do on PySpark is group by and aggregate, right? So we have like census data frame, and then what we can do is we can group by based on, let's suppose, gender. See how autocomplete is working us and, like guiding us what we can do. So we can say group by based on gender, and we can perform the aggregate operation over here, and we can see like which column we want to perform aggregate and what is the type of aggregate we want to perform. We can perform aggregate like average, sum, minimum, maximum, we are seeing in shortly all this stuff. Let's this, we can say we have a column called final weight, which is like equivalent to the income over here. So we are going to perform an average, because this is how we type it, like colon, and then we perform like average, right? Average, and then over here we have this, then we can show the data frame, like how the data set look like, right? So just click on the group by C based on the gender column, and then we are performing aggregate based on the income, and the income is actually average. So let's show this column. See, the output is here. So it displays the gender male and female. It group by based on the gender, which is male and female, and then it perform the average and display the average over here, average income for the female and the male. It group by and it's group together, sum it and club it together, and give the average values from the female column and average value for the male, right? Now, similarly, we can perform some other operations. One way is to like write, similarly, you have average, right? You can also write minimum of that, you can also write maximum of that, and you can also write sum of that, right? But here we can also do, there's another way you can perform this group by is census frame dot group by. So group by based on gender, right? And then in gender we can just simply say, right, sum, we can perform sum, sum of which column, we can say like, let's suppose final wait, column, right? So, and then we can see show. So this is another way to aggregate based group by and then aggregate based on the income column, right? So if you can run this cell from here, you can see the sum, right? It also display the operation name as well while doing aggregate. This is another way you can do aggregate. And similarly, you can do aggregate. This is like the sum of, like, all the female, sum of all the female values in the column for gender, and some of all the values for male column over here. So next thing what we can do is, like, similarly we can do minimum and maximum as well. Census underscore df dot group by based on gender, right? And then we can do dot max. Then we're going to find maximum value from maximum value of the income, right? So we can do right this dot show. Okay, so here you can see, like, we are able to find the maximum and the for both the male and female, the maximum values from the column. This is how you can perform the minimum maximum operations and aggregate using group by. The next thing is the the example of like key functions, like using filter and select, we can narrow down our data frame. So now let's perform some filtration on the dataset. So we have our, let's call it like filtered data frame, right? And over here we have, see how I am naming them as, as more descriptive variable name that will later help you as well. So don't, instead of like taking generic names like df or filter df or something, make it more readable and descriptive, right? So this will help you later on when you try to do and go through your code. It will help you out what you have done previously. Okay, so here filtered censored data frame. So now we can do our original data frame, which is in this variable census underscore df. So we can do like here census underscore df dot filter. This is the function that we're going to apply, and in this we are going to write our census. We are going to get the column, which is this. We are going to get each column in this way, or you can use double quotes or single quotes, whatever you like. Okay, so and then you can perform the filter operation that's greater than 30, right? And then, so here there's like, sorry, by mistake I have put like small brackets. It's like this bracket, which is, we have to put square brackets, right? So small brackets and then census data frame, we have to get the column name using the square brackets, age, and filter it out based on, like, we need to get all the values from the age column from the dataset which are, above 80. Oh, sorry, which are above 30, right? So let's suppose we are now going to select the columns because we are filtering, right? So we're filtering based on age, and which columns we are going to select as an output. We are going to select age. Alongside age, we can do occupation, and then alongside occupation, we can also say income, right? So these are the columns that we are going to display. And then what you can see, you can show your data frame, right? Filter df instead of filter df, because we have census, right? Filtered census data frame, we have to show it. So you can see we have now filtered the dataset from the CSV file and from the data frame that we have loaded earlier, based on age column, and we have like selected age, occupation, and income column. So these are, you can see like all the column that are like, all the age that are above 30 are being displayed over here. So if you want to display this in a nice, you know table like in the database, you can use the display function, and you can type the filtered census DataFrame, right? And you can just display in this display. So see, you have get the nice tabular view of it. So the age is 38, 44, all the age which is above 30 years, right? And we get their occupation and their income level as well from the data set. This is how basically we are performing filtration, we are performing selection of the columns, we are performing group by and aggregate, right? We have explored various methods how to filter, select, group by and aggregate on a data frame. This is how we can perform some key functions on the data frame in PySpark. Hello everyone, and this is the bonus content that I was talking about. I'm still buzzing with energy after attending the Big Data in Healthcare conference right here in London. It was an incredible gathering of minds, and I came away with so many insights. But two major themes really stood out: speed and accessibility. How can we process life-saving data faster than ever before? And just as importantly, how do we get these groundbreaking technologies into the hand of every healthcare professional and patient, not just the specialist? Today, I am sharing my key takeaways on exactly that. First, let's talk about speed. The challenge in healthcare isn't just the volume of data, it's the velocity. We are talking about real-time patient monitoring, genomic sequencing, and predicting models that needs to run in minutes, not days. The consensus at the conference was clear. The future is in unified, real-time data ecosystems. We saw a huge emphasis on technologies like Apache Spark and other distributed computing frameworks, which allow us to process enormous datasets in parallel across multiple machines. Think of it like having 100 chefs working on a single meal instead of just one. The result: drastically reduced processing times. Another key strategy was the data pipeline optimization. This means building smarter, more efficient workflows instead of moving massive raw datasets around. The focus is on pre-processing data at the source, what we call edge computing, and only sending the most critical information for analysis. This reduces bottlenecks and accelerates the journey from data to diagnosis. But all of this speed is useless if the technology remains locked in a lab. That brings me to the second major takeaway: making tech accessible to the masses. The most brilliant algorithm in the world doesn't save lives if a doctor can't easily use it. One of the most exciting trends is the rise of low-code and no-code platforms. These tools are designed for clinicals and researchers, no data scientists. They use simple drag-and-drop interfaces, allowing a doctor to build a predictive model for patient risk without writing a single line of code. This is a game changer for democratizing AI in healthcare. We also talk a lot about the power of cloud. Cloud platforms are breaking down the huge cost barriers that once existed. Hospitals is no longer need to invest millions in their own data centers. They can now access world-class computing power on pay-as-you-go basis, leveling the playing field for smaller clinics and researchers and institutions. This means a small town clinic can have access to the same powerful analytical tools as major metropolitan hospital. So, the future of big data in healthcare is about being faster and more inclusive. By combining the power of distributed computing with user-friendly cloud-based tools, we can accelerate the discoveries and ensure they reach the people who need them most, the patients. It was truly inspiring to see so many people dedicated to these goals. It left me incredibly optimistic about the future of medicine. So, what are your thoughts on this? Do you see these trends in your field? Let me know in the comments below. I would love to hear from you. Thanks for watching, and I will see you in the next video. Bye bye.